You guys for tuning in today. I'm excited to be presenting highlights from basically what I spend the entire year doing, which is putting together the 2024 AI Index report. And whether you're here as a person in industry that is trying to get a sense as to what is going on in this technology, whether you're here in a policymaking capacity and you want to know what's going on with AI, or whether you're just a general person that wants to understand this technology, I'm very excited to have you and very excited to be speaking about trends in this report. So let's actually take a step back first and start with the story of the index. I'm going to be talking about some of these trends. And I mean, I think the first question you guys have is, why should you trust this man? Why should you trust the AI index? What is the AI index? So for those of you that are unfamiliar, the AI index is an annual report that works to quantify and track trends in the space of AI. And it was created in 2017 by a diverse committee of AI thought leaders that really understood that AI was going to be a transformative and groundbreaking technology, and that as such, it was going to be necessary to develop a tool that could really rigorously track what's going on in this landscape. And that's really what the AI index aims to do. We track trends in AI from a diversity of perspectives. We look at trends in the domain of policy. How are policymakers thinking about AI? We look at trends in the domain of economics. How are business leaders reacting to AI? And we look at trends as well in technical performance. What does the data tell us about what AI systems can do now that they couldn't necessarily do before? And of course, we track a lot of other things in between. In terms of the team that puts the report together, I do a lot of the heavy lifting along with Laura Donna, who's our great research associate. But we're really blessed at the AI Index to be advised by a very diverse and rich steering committee of AI thought leaders. People like Jack Clark, who's one of the co-founders of Anthropic. People like Eric Brynjolfsson, who's arguably the leading scholar of AI and the economy, and people like James Manika, who's the Senior Vice President of Research at Google. And it's also important to mention that we collaborate with the diversity of data vendors that give us data that we feature in the report. Of course, we do a lot of data collection ourselves. And the report itself, since its inception, has been fortunate enough to have been featured in a diversity of newspapers. We're cited by governments across the world. And we work really hard to put people in a position to really understand what's going on with this transformative technology. Now, let's actually talk about the report itself. Before I begin, I'll kind of make a note that the report, if you haven't actually read it or flipped through it, is 500 pages long. Now, I wrote most of those 500 pages. So on the one hand, it hurts me to think that maybe if I give you guys 5 highlights, you won't flip through the report. But I'm sure you guys can all promise me that you're going to just dive into it with a lot of eagerness after this presentation. But, perhaps to be a realist, if you guys don't necessarily have that time, I'm going to try to kind of distill some of the highlights of the report to kind of give you guys some of the key takeaways that you need to be knowing in terms of what's actually going on in the landscape of AI. So highlight number 1 is that AI technology is improving. Now, I mean, you're probably kind of looking at this and being like, thanks, man. Like, I don't need an AI index to tell me that it's getting better. And I think that's true. But when you actually look at some of the specific ways in which it has been improving, you'll be kind of impressed and perhaps surprised. So there's a lot of way to talk about the improvements in AI technology, but I think sometimes using a visual example is the most useful. What you're seeing on this slide is the improvements of Midjourney, which is arguably one of the world's leading text-to-image generators, since its inception to now. And one of the things that we did at the AI Index is we asked each version of Midjourney to generate a hyper-realistic image of Harry Potter, and this shows the kinds of generations that you see over time. Now, I think it's probably most useful to actually juxtapose the generations of the first version, which were, again, not that long ago, February 2022, and the generations of the most recent version, which came out in December of 2023. Now, I personally, you could argue that maybe you're more impressed by the one on the left because it looks like an abstract Pablo Picasso-esque rendering of what Harry Potter ought to look like. But I think it really is quite impressive to juxtapose these two images, because on the one on the right, you really have to kind of look close to see that that is, in fact, not Daniel Radcliffe. That is a generation from one of these AI systems. And I think that really makes it clear how much better these systems have gotten and how much they have improved. Now, I think there are a diversity of things to be said about the ways in which these AI systems are improving. One of the things that we talk about a lot in the report is that you're starting to increasingly see AI systems that are more multimodal. What do we mean by this? Well, historically, AI systems, even 5 years ago, were good at a variety of tasks, but they tended to be very good at a narrow subset of tasks. So, for example, an image classification model could perhaps classify images at a very good rate. A speech recognition model could recognize speech at a very good rate, but those models were limited to those particular functions. But that's, of course, not how humans actually think. Humans are quite diverse thinkers. They engage with a variety of inputs. And the newer AI models that you're starting to see, like GPT-4, like Claude, like Gemini, they are able to handle a diversity of inputs. And that's what you're seeing on the screen here. This is an example from Google's research paper, where you can ask Gemini an audio instruction, what's the first step to making a veggie omelet? You can give it an image, and the model will respond with some kind of text. And the ability to engage with different modalities of understanding is becoming an increasingly present feature in some of these newer AI systems. And again, it's something that mirrors how humans actually think and rationalize things in the world. Now, of course, as AI systems have gotten better, there has been a need on the AI index side to actually change some of the ways we're thinking about these systems and evaluating these systems. So let me just ask the audience a quick question here. Who knows what a benchmark is in the world of AI? All right, so it looks like we have maybe 50% of hands that are thrown up, but I'll explain the concept just for the audience that perhaps isn't as well versed. So a benchmark is really just a means and a way to assess how well AI systems are at doing a certain task. And probably the canonical benchmark in the AI world is ImageNet, and this is a benchmark that is really working to assess how well AI systems can classify images. So ImageNet, for example, you have a training set of images that you train a system on, and then you would then test the system on that subset of images and see how well, for example, a system can classify these images, tell you if this is a cat or if this is a dog. So benchmarks are really tests of AI capabilities, and they are ways of measuring how good AI systems are at doing different tasks. We've been tracking benchmarks since 2017, and what you're seeing on this slide is some of the new benchmarks that we've decided to feature in this year's AI Index report. And you'll notice there are a lot of new benchmarks, and that's reflecting the fact that AI systems are becoming increasingly capable, and the things on which researchers are testing these systems are evolving and changing over time. Some of the new benchmarks that we've elected to feature, for example, in this year's report are GSM-8K, a benchmark for mathematical reasoning, MMMU, a benchmark for college-level general understanding, and even benchmarks like Truthful QA, which evaluate how factual the outputs of some of these models are. And this is actually illustrating what you see on some of these new benchmarks or some of these new tests. This is from MMMU looking at some of the sample questions. So some of these AI systems can be tested on questions in art and design, humanities and social science, as well as tech and engineering. And when you look at the scores on some of these benchmarks, AI systems are still lagging behind human expert level performance. Now, with some of the data in the report, it's worth noting as well that we did collect a lot of this data in January of 2024. And for those of you that are perhaps following AI closely or know anything about AI in and of itself, you'll know that the field tends to move pretty quickly. So some of the things that we visualize in the report may not necessarily be the most up-to-date, especially as we move along in a time perspective. But we do try to provide a holistic understanding of some of the benchmarks that some of the key researchers are thinking about and evaluating. So I've talked about how AI is getting better. I've talked about how there's a need to look at new benchmarks. Another big trend that we see in the index is that it appears that human evaluation is in as a means of testing and benchmarking some of these AI systems. So again, when you think about how can you assess how well an AI system can do something, traditionally, a lot of AI researchers looked at things like automated benchmarks, these things that I talked about, like ImageNet, MMMU, which are these collections of questions that you test these systems on. Well, we're now in an era in which AI is generative and it can generate responses that humans actually can evaluate. And that seems to be one of the standards now for assessing how well people like these systems. So, what you're looking at on the screen right now is a screenshot from this leaderboard that's called the Chatbot Arena leaderboard. And on this leaderboard, the way that it works is you can write in a prompt, and you will then get two different responses from two different language models, and you won't be told which language model is omitting which particular response. And that's what I've done here. I'm a history buff, I'm a history fan, so I've asked the Chatbot Arena leaderboard, please explain to me the accomplishments of Otto von Bismarck, and it will give you an answer, and then you can kind of choose which particular answer you like. Is A better? Is B better? Is it a tie? And then ultimately, you can have a ranking of which particular model the general public seems to prefer. And again, at the time that we've collected the data, GPT-4 seemed to top the leaderboard, or a GPT-4 variant rather. But again, this is an important shift in the AI landscape because we're moving away from purely computerized evaluations of what these systems can do, but more so evaluations that are based on how actual people feel about some of the outputs that these models are making. Let's move into some more technical highlights. So one of the things that I was very excited to see, and this is not just true about the world of robotics, but about other AI capability domains as well, is that thanks to a lot of insights from large language modeling, there have been a lot of progress and steps made in other domains of AI, robotics being one of them. So what you're seeing here is a screenshot from the Palm E paper, which was a fairly significant model launch in 2023 from the Google robotics team. And Palm E was a significant robotic development in that it was a robot that was able to not only engage in manipulation tasks, but also engage in manipulation tasks that involved certain degrees of reasoning. For example, stack the blocks by size or stack the blocks by color. And Palm E was not only trained on data of robotic manipulations, it was also trained on data of language, and it was trained on an extremely large corpus of language data. And the fact that you have these robotic agents now that are not only capable of doing manipulation tasks, but tasks that involve some degree of, let's say, kind of thinking, is a very exciting development in the field of AI. Another area where AI researchers, at least on the technical side, really seem to prioritize and think about a lot this year was research into agentic AI. So AI agents are systems that can kind of operate in environments, for example, do your web shopping for you, perhaps browse the web or hold the house. And what you're seeing here is a description of tasks on the Agent Bench benchmark, which is a new benchmark for actually evaluating AI-based systems. And again, there's some research that certain models like GPT-4 and Claude 2 outperform others. But I think the important thing to kind of note here is that as AI systems have become increasingly more capable, researchers are also pivoting focus to pay attention more to some of these more difficult and technically demanding challenges like agentic AI research. And a few concluding thoughts when I talk about, again, how AI has actually gotten better. One of the things that I think is sometimes missed when you look at discussions of trends in AI, and I say this is missed because if you kind of log on to Twitter, everybody's always talking about GPT-4, Claude, Llama 3, is the fact that there has been tremendous progress made in science as a result of AI. So much so that we actually included an entirely new chapter in this year's AI Index that is dedicated to ways in which AI has been used to accelerate science. And we talk about a lot of different developments. but I'll talk about a few that I think highlight a broader point. So what you're seeing on this slide is you're seeing the results of a Google research project called GNOME. And this project was basically designed to try to identify new crystal formations that could be used for the construction of different materials like semiconductors. And you'll notice that in comparison to the material project, which was the previous state-of-the-art result before, the previous best system, GNOME was able to discover a substantially greater amount of crystals. And you're not only seeing this kind of progress in the domain of science, you're seeing it as well in the domain of medicine. What you're looking at here is the predictions of a Google system known as alpha-luminescence. So alpha-luminescence, for those of you that are unfamiliar, is a system that was developed by Google to classify luminescence mutations. Luminescence mutations are mutations of human proteins. They can be benign, they can also be pathogenic. And the important thing to note for your purposes is that scientists estimate that there are close to 70 million, if not more, such luminescence mutations that actually exist. Prior to alpha-luminescence, human annotators were able to successfully annotate 0.1% of all of these 70 million mutations. So again, 0.1%. Then alpha-luminescence comes along, and alpha-luminescence has so far been able to successfully classify 89%. So we go from 0.1 to 89%. And I think these scientific gains and this scientific progress is really illustrative of the fact that there's a lot of problems in the domain of science that could really be aided by systems that have the computational strength of some of these increasingly strong AI systems. And we're starting to see these systems that are able to aid and solve a lot of these problems. And that kind of leaves us at a point where, we're now at a level where AI really is exceeding performance on a variety of different tasks. And I think this to me is probably one of my favorite charts from the entire report. But in this chart, what we did is we looked at different benchmarks that represent different human task categories, like image classification, visual common sense reasoning, competition level mathematics. And we looked at how well AI systems have been able to do on these tasks relative to a human baseline, which is at 100% over time. And you'll notice that for a lot of these tasks, there is really, AI systems are exceeding the level of human baseline performance. And there's really only a few tasks now, namely visual common sense reasoning and competition level mathematics, where these systems are not necessarily exceeding humans. Now, I think there are two stories here. There's not only a story of the fact that AI systems are becoming increasingly capable, but also the pace of improvements is rapidly increasing and really skyrocketing. You'll notice on the left, the first benchmark that we talk about, ImageNet, again, I had mentioned earlier how this is one of the canonical benchmarks in the world of AI. ImageNet was a benchmark that really served the AI research community for 5-6 years. They could really test this benchmark and use this benchmark for a while. And it took several years to go from a performance level that was close to 90% relative to the baseline to, again, above that standard. Whereas fast forward to now, this line that you see here is the benchmark for competition level mathematics. And we went from AI systems that were very bad at competition level mathematics in 2021 to very good, if not close to the human standard in 2023. And by the way, the human standard for that particular benchmark is the performance of a 3-time International Math Olympiad gold medalist. So these systems are getting better a lot more quickly, and that's really changing how we have to evaluate and think of these systems. So that's highlight number one. Now again, highlight number two, perhaps not surprising on the macro level, but I think the micro is quite indicative here, which is that businesses are now starting to respond to AI. And I like to lead when I do this presentation with the technical highlights first, because I think it really makes clear how much better this technology has gotten, and everything else that follows in a lot of ways is a function of improvements in technology. And if there's really kind of a narrative or a story that I would like to read to leave the audience with, again, just in case you don't have the time to flip through the report in its entirety, is that AI has gotten good, and it has gotten so good that people have started to respond, whether it's people in business, whether it's people in policy, or whether it's regular civilians. So how do we see this kind of business response actually occurring? Well, first and foremost, there has been a massive increase in the amount of private investment in generative AI technology. In 2023, there was close to $25 billion invested in generative AI technologies, compared to just $3 billion in 2022. And again, we profile this in the index report, but there were really a few massive fundraising rounds in OpenAI, Cohere, Anthropic, Inflection that really signified the degree to which the business community has woken up to the fact that this technology is here. Now, when you actually zoom out and you don't just consider generative AI investment, but you consider total AI private investment, there has interestingly actually been less of that investment now than in 2021. Now, this may seem slightly anomalous, but I think this reflects the fact that more broadly, there is less venture capital investment now than there was 3 years ago as a result of changing global macroeconomic conditions and differences in interest rates. But although there is less total private investment in AI, there are more newly funded AI companies in the world. And this is again suggestive of the fact that there are more players in this game, more startups and more companies that are realizing that AI is this technology with which they can do really meaningful things, and this technology that they could use to build meaningful applications that could potentially help others. Businesses are also responding on the organizational side. This is data from a McKinsey survey that is asking business managers whether they're using AI in their operations. And you'll notice that since 2022, there's been a slight uptick, and since 2017, a fairly large uptick. Now, interestingly enough, I dialogue closely with the people at McKinsey that have given us this data, and they've noticed that for the first time this year, they're actually hoping to do this survey twice a year, because they're really anticipating that in the next few years, in the next few months, the pace of business integration in AI is going to massively increase and massively going to go through the roof. And another way that you see this, at least from the perspective of major companies, is that the number of Fortune 500 earnings calls that mention AI have also really gone through the roof. And I'll probably come back to this term a few more times in the presentation, but in some ways you could call this the ChatGPT effect. You'll notice that since 2018, there's kind of a steady rise. 2022, ChatGPT is launched, and then boom, we're kind of at a level now where we go from close to 50% of major companies mentioning AI to close to 80%. So businesses are responding. Businesses are kind of thinking about this technology. Now, the question I think you would ask then is why? Why do businesses care? And I mean, that may be obvious. AI is exciting. You kind of log on to ChatGPT. You can ask it a question, ask it to make you a recipe to design your next workout. But I think there's a lot of really good data in the index that really makes it clear why companies are thinking about AI in the way that they actually are. And this is, I think, one of probably the most important charts in the report, not only because it looks very pretty and it took our team a long time to actually figure out how to design this on Python, but because there is an important conclusion here. So this is, again, coming from McKinsey. And McKinsey is asking business managers that are using AI, what percentage of them report realizing cost decreases and revenue increases from adopting AI? And you can disaggregate this information by function, but I think the most important thing you need to pay attention to is this average across all activities. So what this is suggesting is that 42% of respondents report realizing cost decreases as a result of integrating AI, and 59% of respondents report realizing revenue increases as a result of using AI. Now, I'm not a businessman, I'm just a humble academic, but I do know enough that if you're putting your business in a position to decrease costs and increase revenue, all else being equal, you're putting your business in a position to make itself more competitive. So there's now data that exists that suggests that businesses that are integrating AI are really realizing a lot of tangible advantages and benefits. For the kind of economics fans in the room, this data I think is particularly interesting, and I think also very valuable because for a very long time, I think there's been a lot of questions that economists have been asking about AI. Is it going to lead to more productivity? Is it going to help people? Is it going to hinder people? There's now a lot of data that is suggestive of the fact that AI actually does make workers more productive, and it does actually lead to higher quality work. What you're seeing here is you're seeing the amount of time that it took a group of users to do a subset of tasks. One of the users, or one of the group of users, they had access to Copilot. Copilot either being GitHub's code writing assistant tool, or perhaps Copilot being Microsoft's productivity suite of AI tools. And you'll notice that across these different studies surveyed, the groups that had access to AI technology finished their tasks in either 73 or 26% less time relative to the baseline. And you don't just have that research coming out of a small sample of studies, you have that research coming really out of a diversity of studies. This was another really important and seminal piece of research that came out of the Harvard Business School, where again, they gave one group of consultants GPT-4, and they gave another group of consultants nothing. And the group of consultants that had GPT-4 were more productive, they got their work done a lot quicker, and their work was of a substantially higher quality. And you see a similar trend in a similar analysis when you go to the world of law. Lawyers and legal students that used AI tools did work that was of much higher quality and also did work that was substantially quicker than those that didn't have access to AI tools. Now, I will caveat this by saying that we do profile another study in the AI index, which I think kind of is an important addition to this point, which is that although AI can enhance what you do in your workplace, it's still very important and it's still very critical to leave humans in the loop. Now, in this other study, what they did is they had three groups. They had one group where they didn't give any AI to. They had another group where they gave AI to the group, but they told them this AI tool is actually, it's good, but it's sometimes prone to making mistakes. And then there was a third group to whom they gave AI, and they told them, yeah, it's a great tool, like use it, like it's really good. Now, when you compare the performance across these three groups, the groups that had AI did better than the group that didn't have AI. But of the two groups that did have access to AI, it was actually the group that was given the kind of quote unquote bad AI that did a lot better than the group that was given the good AI. And the researchers speculated that what you had here is kind of an autopilot effect, where humans, when they're kind of told that these AI systems are very good and they're very reliable, just kind of shut off their cognitive functions and let the AI systems do the work. But it's really clear that these systems, although they are very capable, they're still prone to hallucinations. They're still prone to misrepresenting information. These are things that we talk about in the AI index report. So for the business people in the audience, I think there's a really important takeaway that it's not just a matter of using AI, but ensuring that you use it with a human in the loop and a human doing supervision. And I mean, the business impacts of AI are going to be increasingly important to monitor because we're just starting to scratch the surface of AI being used in a business setting. This is coming from a McKinsey survey that is asking business managers what they think the expectations of AI is going to be on their workforce. You'll notice that 30% report or they anticipate little to no change. And if you sum up the decrease section, 43% of respondents think that AI is going to lead to a decrease in the workforce compared to just 15 that think AI is going to lead to an increase in the workforce. Again, we don't know if this is actually going to happen or not, but the point here is that AI is kind of the cat is out of the bag, and we're going to have to increasingly track the ways in which business managers are actually integrating AI and thinking about AI. So I talked about how businesses are responding. The third highlight that I have for you is the fact that industry is really dominating a lot of frontier research. I'll talk about what this means, and I'll talk about what some of the consequences of this are. So if you look at data on where some of these notable machine learning models are actually coming from, the data, and I think this chart really speaks for itself, is telling us that it's increasingly the case that the majority of notable machine learning systems are coming from industry actors. You'll notice up until 2020, up until 2014, the blue line, the dark blue dominates. The majority of notable AI systems were coming out of academic institutions like Stanford. Since then, a massive gap has opened up until the point where in 2023, there are 51 notable machine learning models coming from industry settings compared to just 15 that are coming out of academic settings. And you see a similar breakdown in trends when you look at foundation models. So for those in the audience that don't know what a foundation model is, a foundation model, for example, Gemini, Claude, or GPT-4, is an AI system that is trained on massive amounts of data and can really be used on a variety of downstream tasks. So tracking foundation models and trends in foundation models can be a really good way to track where the level of frontier AI research actually is. And again, when you look at foundation models, it's a very similar story. A significantly larger proportion of foundation models are coming out of industry labs compared to academic labs. And again, what do I mean by these industry versus academic labs? You see that in this slide. In the pink, industry labs like Google, OpenAI, Meta, Microsoft, DeepMind, they're really dominating AI research and really kind of outpacing the number of publications, at least on a frontier level, that are coming out of these institutions compared to, let's say, Stanford, Berkeley, or other competing academic institutions. Now, you may be wondering, why is this the case? Like, why is it the case that industry has all of a sudden become this breeding ground for leading AI research? And I think there is a variety of narratives or a variety of stories to be told here, but I think this is probably the main one, which is that it's just become substantially more expensive to train these frontier AI systems. So I'll ask the audience another question here. Who here knows what a transformer is in the context of AI? Okay, so I think a decent number of hands in the room. But for those that are, again, unfamiliar, uninitiated, the transformer architecture, which was introduced in 2017, is the architecture that in a lot of ways is really the backbone for a lot of modern large language models. So a lot of these modern systems use some kind of transformer architecture that is really scaled up, is being really trained on way more data. Now, when the transformer paper was released in 2017, we estimated at the AI Index that that model cost $1,000 to train. You fast forward to 2023, and some of the leading AI systems like GPT-4 and Gemini, we estimate respectively cost anywhere between $80 to $190 million. Again, that's an obscene amount of money. And you might be asking again, why are they so expensive? Are they just paying their engineers a lot? What's going on here? The story is one of scaling and computation. So again, for those of you that are unfamiliar, a few years ago, there was a paper published about the scaling laws in AI, which talked about how, all else being equal, if you train an AI language model on more data, you're going to get improved results. So naturally, what a lot of these companies have started doing is they've started really scaling up their systems, training their systems on more data. But when you train systems on more data, you need a lot more computational resources to support that kind of training. And that's what you're seeing in this chart. This chart is giving you the estimated cost and computational resources associated with the selection of notable AI models. On the x-axis, you have the training compute, and on the y-axis, you have the cost in dollars. And it's a pretty linear relationship. The more compute that a model has, the more expensive it is. And again, this is going to be a trend that's going to be increasingly important to monitor and pay attention to in the near future. And it's not just the case that AI systems are becoming a lot more expensive. It's also the case that a lot of leading AI talent is increasingly migrating to industry. In 2010, roughly similar amounts of AI PhDs went to industry as went to academic institutions. Since then, of course, a massive gap has opened up. Now, we'll talk a little bit about the implications of this industrial dominance, but it manifests itself in several different ways. So One of the facts and one of the ways in which it manifests itself is the fact that if you look at the performance of different models, closed AI systems really seem to be outperforming open ones. Again, for those in the audience that are unfamiliar, when you release an AI model, you could release it in different ways. A closed release generally means that model developers are not openly releasing the weights of the models, which means that the models cannot be freely and openly modified. So when you release a model in a closed way, either you release nothing about the model, like Paul Me, for example, you can release it in a limited way where you allow people to access the model via an API, like ChatGPT or perhaps Claude, or you can openly release it like Meta does with its Llama models and say, here are our weights, anybody can use them. On this chart, what you're looking at is you're looking at the performance of top closed versus open models on a selection of benchmarks. And this is looking at the differential. How much better do closed models do versus open models? And basically, for the universe of benchmarks that we consider, closed models substantially outperform open ones. Again, why should you care about this? Well, open models are ones that the research community can freely develop and freely utilize. And there's a lot of researchers that could really benefit from using AI technologies, like university researchers that are perhaps doing groundbreaking, cutting-edge scientific research. And if it's the case that closed developers are substantially outpacing or substantially outperforming developers that are open, this could have a lot of implications for how democratic and how widely distributed the benefits of the AI revolution could possibly be. There are also important consequences for transparency. There was a project that came out of Stanford in 2023 that we featured in this year's AI Index called the Foundation Model Transparency Index, which looks at how transparent some of these developers are. Now, I'll note that there's going to be an update to this project in a few months, so keep your eyes peeled for that. But this project really tried to assess how transparent some of these different developers are. Again, most of them coming from industry, and you'll notice a lot of them score very poorly, but it's the ones that are open that tend to, all else being equal, do a bit better than the ones that are closed. So these kind of questions of how open these models are and how accessible they are have a lot of important implications when we think about transparency in the AI ecosystem. Industrial dominance of AI also matters a lot when you think about how these models are being standardized and how they're being tested. So this was one of the top 10 highlights of the report. And what we did for this particular highlight is we chose a subsection of AI developers like OpenAI, Anthropic, Meta. We chose a flagship model for each of these developers, and we looked at what benchmarks these developers are testing. So again, what tests are these developers using to identify what the capabilities of some of these systems are? And you'll notice that when it comes to general capabilities like mathematical understanding, language understanding, there does actually seem to be a consensus with a lot of these benchmarks. So of the developers that we surveyed, for example, MMLU, which is a benchmark for general language understanding, for Codex, which is a benchmark for computer science knowledge, and GSM-8K, which is a benchmark for math, all of the developers that we profiled tested their models on these benchmarks. So you could really do a standardized comparison and say, okay, GPT-4 did this well versus Llama did this well. Now, when you actually shift the playing field to the landscape of responsible AI, it changes massively. There is no consensus. There is no standardization. Some of these developers are testing on truthful QA, a benchmark for factuality. Some of them are testing on toxicity benchmarks like ToxicGen. And some of them are testing on benchmarks for bias like BOLD or BBQ. But the fact that there is no standardization carries with it a lot of important implications. It's unclear if these developers don't have a standard subset of tests because they're either cherry picking particular benchmarks that they think best serve their model and best represent their model, or if it's the case that they genuinely believe that one benchmark is perhaps much better suited for testing than another benchmark. Now, I'll kind of close this section on industrial dominance by saying that it's not the case that the open ecosystem is completely far behind. I mean, we profile where these foundation models are coming from by access type, and in 2023, there were more open foundation models than ever before, Again, it's just the case that the closed ones seem to be doing a little bit better than the open ones. And if you look at, for example, GitHub AI projects, there are more of these projects than ever before. So the open community is doing well. It's just the closed community seems to be producing models that are perhaps of a substantially or notably better quality. Fourth highlight for you guys is that policymakers are reacting to AI. How do you see this reaction? Well, again, you could call this the ChatGPT effect. If you look at mentions of AI in global legislative proceedings, which we did at the index, you see a steady rise until 2022 and then really an explosion in the last year. And what you saw in the last year in 2023 was several landmark policy actions really across the globe. In the United States, you had Joe Biden's executive order on safe, secure, and trustworthy AI. There was a EU AI Act, which was realized in the European context. And if you zoom in and you kind of look at the American policymaking landscape, you really see this kind of explosion in a pretty pronounced way. This is looking at the number of AI-related bills in the United States on a federal level that are proposed versus passed. Again, since 2022, there has been a substantial increase in the number of bills that have been proposed. Not as many have been passed, but again, it takes a while for federal level bills to get passed. And you see a similar thing when you look at the state level. There is an increase in both proposed bills and passed bills, and very interestingly enough, a lot more passed bills at the state level. And I think when it comes to looking at AI policymaking, states can sometimes act and respond a little bit more quickly than federal legislators and federal policymakers. So looking at some of the state level action can be a real important perspective on what's going on in the AI landscape. You also see an increase in the number of AI-related regulations. So an AI-related regulation, or at least one that we considered, was one that came out of a regulatory agency in the United States, like the EPA, the FCC, things along those lines. And again, I could just probably repeat what I said the last 3 minutes, but there's been a substantial rise from one such regulation in 2016 to 25 in 2023. And I'll note as well that it's not just the case that these regulations are coming from one or two agencies. You really see across the board regulatory action. The Commerce Department is thinking about AI. Health and Human Services is thinking about AI. The Executive Office of the President is thinking about AI. And trends like these are really indicative of the fact that AI is this general purpose technology that people think about on a very broad level, and that regulators are certainly thinking about on a broad level. Regulations are also becoming a lot more restrictive instead of expansive. At the AI Index, we kind of separated regulations into two types. Are they restricting how AI capabilities can be used? So for example, a regulation on if you want to use a facial detection algorithm, how you need to use it, how you need to launch it, or are they expanding AI capabilities? For example, giving money to construct a network of supercomputers. You'll notice that on the AI regulatory side in the United States, there is much more restrictive regulation, which is again probably a nod to the fact that policymakers, they see that this technology is here and they understand that something needs to be done to kind of rein in how it should potentially be used. Now, there's a question to ask about why policymakers are kind of reacting now. Why are they thinking about this technology now? And of course, it's obvious that this technology is game-changing, but there's also, I think, the public opinion side to the narrative as well, which is that people are waking up to this technology. And I think this is probably, for me, one of the most interesting insights in the report, is that if you look at how people feel about AI in the last few years, there's a lot more nervousness. This chart is looking at the percentage point change in opinions about AI by country. So Ipsos, it does this survey where it asks people a bunch of AI-related questions. It asked this question in 2022. It asked this question as well in 2023. And you'll notice that for the question, do you agree with the statement that products and services using AI make me nervous? Compared to 2022, there has been an increase in the number of respondents that report nervousness in every single country that was surveyed. You see this as well in America. Americans are, in 2023, substantially more concerned than excited about AI technology, and that's the first year in which you really saw that breakdown. And that, again, is a really emerging trend. People feel differently about AI depending who you survey. Boomers and Gen Xers are a lot less optimistic about AI than people that are in the Gen Z generation. People that are richer feel better about AI than those that are poor. People that are better educated have a similar breakdown in opinions. And again, the takeaway here is that AI it's no longer this kind of product that is in the lab. It's something that's here. It's something that's affecting all of us. And policymakers are reacting because people are reacting. People are thinking about this tool and how it's going to be used. I'll conclude the presentation with a fifth highlight on some geopolitical considerations. Who's leading the AI race? Well, if you look at, again, these notable machine learning models, it really appears to be the case that the United States leads China and other countries as the leading source of these systems. And when you look at foundation models, where are these models coming from? Again, you see a fairly similar narrative that there are certain countries that are really leading the charge in terms of developing these frontier AI systems. Also, on the investment front, that's another domain where America really is outpacing its competitors. If you want to be doing AI investment work, you need to be in the United States. Well, you don't need to be in the United States, but the United States, again, is seeing much more private investment in AI than most other major geographic areas like the EU and the United Kingdom, as well as China. Now, I think on a lot of major metrics, the United States does a lot better than other nations in the world. But probably if you were to identify a country that's kind of number two, you would say China. And China is also doing well in certain areas, like the number of AI patents that are granted, as well as industrial robotic installations. The robotic installations is particularly an area where China really just kind of outpaces its competition completely. Since 2021, China has installed more industrial robotics. Again, these robots often use AI tools than any other country in the rest of the world. So that concludes the presentation. I've intentionally left a lot of time for audience questions. There's a QR code to access the report if you guys want to, again, do that front to back read, which you guys have all promised me, so to speak. And I think before I kind of go into the questions, I will leave you guys with perhaps a concluding thought, which kind of speaks to the message of the AI index and the kind of message of what the index is actually trying to do. Again, the index is trying to tell a story of what is going on in AI so that people, whether they are in business, whether they are in policy, whether they are just regular people, can make informed decisions about this technology. And I think when the index started in 2017, a lot of people still really felt they had some time to spare with this tool. I mean, AI was there, but it wasn't quite in all of our lives. Well, we're now at a moment where AI is here and it's affecting everything that we do, and it's going to be increasingly used by businesses. Policymakers are going to be increasingly thinking about it, and everybody now has a responsibility to really ask themselves how they feel about this technology, because at the end of the day, citizen opinion is going to be really important in telling the narrative of how this technology develops and how it is ultimately integrated. So thank you for your time, and I'm excited to answer some questions about the report. You want to do audience questions first and then go to Zoom? In-person audience, that is.
Thank you for your talk today. I'm curious, within the 2024 AI Index, if there's been research done on the education front, particularly how ChatGPT or large language models are going to impact students' education, and then if there should be an institution response or how educational landscapes should be responding as they're getting better at perhaps doing complex coding tasks, writing essays, etc.
Yeah, I think that is a good question. So we actually do have an entire chapter on education. I just had to leave some things off the slide deck. Otherwise, I would have kept you guys here until 8 p.m. But yeah, we do have some data on this. There is some surveys that have been done. that I've asked teachers and students how they feel about ChatGPT, and they actually feel pretty optimistic. Like a lot of them agree that it's important, it's a valuable tool. I think the AI index stays away from kind of making normative claims about like what should be done in certain domains. But I mean, AI is here and it's not, you can't kind of, put your hands on your ears and pretend that it's not. I think if you're an educator and you're a teacher, you really have to acknowledge the fact that this tool is here and change pedagogically maybe how you teach or how you add certain assignments. I know certain teachers that I've spoken to or certain professors that I've spoken to, they've talked about how now they do some assignments where they will have students generate responses from different language models and evaluate which response is perhaps the best, trying to see if there's any hallucinations in some of the responses. So we do talk about education in the index, and it's not probably for us to say that, if there should be an institution or what exactly should be done, but I think it's unquestionably the case that the landscape has changed and teachers do need to be responding to that.
So, great talk. I really liked it. So, I had a question. You have these graphs in the report that talk, and you mentioned them here about the cost, increase training, but for a given performance level, I was interested in seeing how the cost of training that performance level is going down. So, because I've seen a lot of in the open source movement, how they're trying to make it more approachable to train and how that's going very fast. But just wanted to know if you can
I mean, I think that's also a part of the story as well, is that like, even though frontier models are going to be increasing in their costs, model developments are going to get more efficient, hardware is going to get better. So you could probably, it might be the case that in a few years, you could get a model that performs comparably to GPT-4 that is a lot less expensive than the amount that OpenAI trained GPT-4 on. But I think at least at the frontier, a lot of these leading developers are still kind of betting that scaling is a real effective means of actually building these better AI systems. And they're just kind of putting the foot on that gas pedal and going forward. But it doesn't necessarily mean that you won't have efficiency gains. And I think in the future, you probably will have good performing models that aren't as expensive to train.
Thanks.
Why don't we go over there? Yeah.
Okay.
The whole study yet. Sorry, at the risk of displaying the fact that I haven't quite read the whole study yet.
How dare you?
Yes, I'm sorry that I'm the only one in the room for whom that's the case. My question is, the study you mentioned about the good GPT and the bad GPT and the no GPT. What was that study, please?
I don't know the name of the study off the top of my head. It's in the economy chapter. It's by Delacroix. It's in the chapter, and there's a section in that chapter on labor impacts. So we link the study, and you can give it a read if you want to look at it in a bit more detail. And we'll go over here.
A question from a business perspective. Most enterprises are interested in efficiency, especially in low complexity transactional work, or even high complexity knowledge work. How much do they need to worry about selecting models, getting into the conversation of which models to adopt? Or is there an approach where they can sort of use a more abstracted approach, where they don't need to chase and figure out which is the latest model that works best, considering the models are proliferating constantly?
Yeah, I think it's a good question. I think one thing to say is that businesses do different things. That's obvious. And I think these models also perform differently. And this is maybe, again, outside the scope of the index, but I think, the index is trying to measure how well these models perform on a variety of tasks. But a lot of these benchmarks that I talked about in the presentation, they're quite academic, right? So when these developers launch a new AI model, they'll test on all these benchmarks and they'll say like, oh, our model does 95% on GSM-8K. We can solve grade 8 math problems at that level. Therefore, our model is the best. Obviously, a bit of an oversimplification, but businesses are probably not solving grade 8 level math problems. They're doing different things. And if you use these tools in different settings, you will find that they perform differently. So for the AI index this year, I actually used, as the author, some of these large language models to copy edit some of my text. So I would draft my text originally, then I would ask GPT-4 to copy edit, and I would sometimes ask Claude to copy edit. And let me tell you, these models performed very differently. For whatever reason, GPT-4 loved using the word surge, which I thought was very bad. I didn't like it. So I would tell it, stop using this word, and it would forget in 3 instructions and continue using surge. Whereas I thought that Claude didn't really have that problem. I think kind of on a broad level, the point I'm trying to make here is that these models do perform differently, and I think businesses do need to be thinking about some of the kind of considerations when it comes to how these models perform differently. And it kind of, I think, on a broader level, speaks to the need for there to be other businesses or perhaps other startups in the space that are kind of helping companies understand which models are best suited for their application, maybe kind of helping them build out some of these custom applications. Yeah. Why don't we go over there, Mads? Thanks.
Hi, thank you for the great talk. I was curious about maybe how the shift you pointed out of both AI talent and like top AI models from academia, like places like Stanford, to industry has affected the workflow at HAI, or your ability to kind of do this kind of really important work that you do. I imagine that, for example, 5 years ago, maybe the state of the art was down the hall from you and it was kind of very freely available. And now that it's increasingly a trend to be closed, is it more difficult to have for HAI to have a finger on the pulse of what exactly is going on broadly in the industry?
So it's a great question. I mean, I'll kind of note I'm not a computer scientist. I'm just a social scientist masquerading as someone with some computer knowledge. But I'll say a few things. I think there is a need to kind of level the playing field, and I think HAI has done a lot of advocacy work where it has petitioned government institutions like the Office of the President to give more resources to universities to actually be able to kind of have the compute to build some of these systems. Now, I mean, I think if you're in a university setting, you need to be honest with what you can do. Stanford is probably not going to be able to shell out $500 million to build the next best model. But I mean, building a frontier LLM is only one component of AI research. There is so much more research to be done in AI. These systems still struggle with planning. We talk about that a lot in the report. They're still prone to hallucination. These systems, there's still a lot that needs to be done on the architectural level, understanding how these systems work. And I think there's a lot of room for academics to be doing that kind of work. I think there's a really open question in the AI community, like when are we going to get AGI? Like when are we going to get these systems that could operate on a human level? And kind of putting aside the fact that I think there isn't a standard definition for what AGI even means, I think there's a lot of people in the community that really believe that just scaling LLMs or just building these bigger transformer-based models is not going to be enough to actually get us to that level. And maybe we're going to have some kind of new architectural development. And you could imagine something like that coming out of a university atmosphere. So I think that academics still play a very important role. I think it's just that the role that they play may have to change slightly. And I think they have to be transparent about what they can and cannot do and focus on doing very important work that perhaps industry actors aren't necessarily concentrating on. Yeah, I think.
Great talk, Nestor. Christine in the back here. I'm serving as the voice of our Zoom audience. We have a few great questions. One of the most popular is, does the index include any data on the climate and environmental impact, especially as compute grows exponentially?
I love these questions because we actually do include that data. Again, I had to leave it off the slide deck, but we do include that data at the end of chapter 2. And the story is actually mixed. I mean, in the sense that there are a lot of things that determine the amount of energy that an AI system uses when it trains. Now, all else being equal, bigger systems are going to require more compute to train, and they're going to be more carbon intensive. At the same time, if you train your system on in a data center that is using an energy efficient grid like nuclear versus one that is using something like coal, the energy impacts are going to be a lot lower. So it really depends. We do have some data at the end of chapter 2, but it's a really multifaceted story. It's not just really the case that there's been a massive linear increase. It really depends, again, on how big the model is, where you're training it, also on the utilization of hardware, how efficient that is. So there's a lot of layers to the story and a lot of layers of complexity.
Hi, so I have a question. So as more people adopt ChatGPT and other similar Gen AI tools, are you concerned that this is going to lead to some kind of convergence of sorts and that it will actually stagnate human creativity and innovation? And so a lot of these models are clearly being trained on data that we've collected, since the beginning of time. But, nonetheless, I know that, they get fine-tuned with new data, but as the newer generation become more and more reliant on these models and they become more and more powerful, what is the social ramification? Because it's almost like our generational memories are going to be in these models. And if the newer generation are going to be reliant on these models, how will they, I guess, rise up in terms of creativity and whatnot?
So I think, I think there's an open question as to how creative these models can be and what does it even mean to be creative, right? So I showed the images earlier of the Harry Potter generations. It seems like Midjourney can give us really good Harry Potter generations, but can an AI system actually create the next Harry Potter? In the 80s, there was no Harry Potter. Someone had to conceptualize this wizarding world. And can an AI system, build that from scratch? I think that's still very much an open question. So we'll see how much these technologies progress and how much they develop. But I still think there's kind of an open question there. I also think more broadly, if you look at the history of technology and creativity, I think technology develops and humans respond, right? So if you look at a lot of developments in the artistic movement, development in impressionism and kind of more surrealist styles, in a lot of ways were responses to the fact that there was less of a demand for realistic depictions in the world of art because the photograph had emerged. So I would presume similarly, there's going to be reactions in the world of art to the new AI technology that exists. And I mean, if we want art that is just a repetition of what we already have, like if we want just more Harry Potter fanfics or perhaps, more Marvel movies, then I think AI could do that well. But if we want art that is creative, that is perhaps outside of the scope of what we already have now, then I don't necessarily know if the systems that we have at the moment will be able to do that. I think we have a question about back there as well.
I just wanted you to comment on some of the points you made. I mean, one of the things I really got from your talk was how much this is going on kind of privately in closed systems, industry dominated. That's been kind of one of your themes. And you talked about the lack of robust and standardized benchmarks, that they were actually lacking. And then you went on to talk about the proliferation of government policies, regulatory policies. And I wondered if you could comment on the connection between those two things, as they're two of your main points. And then just a kind of cautionary comment, which is that I'm a sociologist of work, and I know about McKinsey surveys of employers, and there's a long history of employers, as soon as businesses invest in technology, they are going to say that they're productive and, that they are increasing productivity. You'll rarely find a business answering a McKinsey survey saying we spend a lot of money on this technology and actually, it's been counterproductive or it hasn't worked at all as we thought it might. Just a cautionary note on that data.
Yeah, I think that's a good point. And I think that more broadly speaking, I think that that's going to be an open question. I mean, as I said before, AI is now being used by a lot of businesses. So I think there is this question of, can we have some robust measurements of how it's actually affecting the labor market? Is it actually leading to increases in productivity? And we're fortunate at High to be working with a lot of economists that are thinking about some of those questions. So I think for us, that is kind of, I think, the best snapshot that we have, but we're continually working to think about new ways to do some of that representation. And yeah, I think that, regarding the government policy and the lack of standardization, I think there is an open question as to kind of what role government should play in the AI ecosystem. And it's not really up to the index to kind of make a claim one way or another. But you could imagine that there is a lot for governments to do. Governments can step in and they can say, here's, whatever, $500 million for universities to train AI systems, which again, some governments in the world have done. Governments can also say like, oh, if you're using an AI in business, this is what you need to be doing. Here's a standardized set of transparency requirements. So I think I think we're kind of at that stage now where because AI has entered the zeitgeist, everybody's familiar with it. There is a need to, I think policymakers understand that they do need to act now, and something does actually need to be done about these systems, but there is still kind of an open question as to what exactly is the right course for action, or what exactly the right thing that could be done about some of these systems. So I think we have 5 minutes for maybe 1 or 2 more questions.
Thank you very much for the presentation. My question is mainly concerning how effective these restrictive policies have been. I imagine it's going to be more difficult than some other policies to enforce. And do these restrictive policies perhaps inhibit innovation? And are they maybe trending to become too general and too broad? Thank you.
Yeah, so that's a good question. I think we don't have good answers to that at the moment because the analysis that we've done so far has been fairly high level, but that's a subsequent step we'll be taking in that project, doing work to kind of disaggregate what the effectiveness is going to be. But of course, I think that's kind of a concern for a lot of regulators. On the one hand, you want to protect the public from ways in which AI can be misused, and there are a lot of different misuse possibilities. But also, I think there's a recognition that AI, again, could be this technology that could really level up your workforce, that could lead to a lot more productivity. And I think governments are really working to strike that balance well. So we don't have a completely satisfying answer as to, for example, if these restrictive policies are maybe hindering innovation, but it's something we're mindful of and working to kind of track in the near future. One more question, I think. Yeah, let's go over there.
Hey, thanks for the presentation. So on the slide where you talked about people getting efficiency gains and revenue gains from AI, I was wondering if you found out any specific use cases that people were actually leveraging to drive those advancements in both fields.
So what do you mean by that?
So in industry, you talked about like manufacturing, a lot of people in different industries driving forward productivity, revenue, and efficiency. What exactly were they using AI for to get those efficiency gains and revenue gains?
Yeah, that's a good question. So I don't think we have the data. I'm trying to think of that survey. I don't necessarily know if we have the data that could precisely say like, oh, we got revenue gains because we used AI for this. We do have data that suggests how different businesses are actually using AI. And I think a lot of it is to kind of create personalized products, to kind of make certain processes more efficient, more streamlined. But I think that question also ties into a lot of other questions that have been posed, which is that, there are so many questions in the world of AI for which there are not really satisfying answers, right? Like in the business setting, it would be great if you can have a study that could say very definitively, like, if you use AI for this function, this is how much you're going to boost your productivity. These are the industries where you could use AI to really boost functions the most. We don't really have, I think, good comparisons on that level of granularity, but it's something for the research community to be thinking about more broadly. I think I've gotten assigned one final question.
Thank you. I downloaded the report and I searched for the keyword military. Appears only 3 times, mostly are quotes. And I wonder if there is in the academy or in the industry some concern, or actually there is not. Because personally, I have some.
Yeah, I think there definitely is a lot of concern. I think there's a few things to be said about this. We talk a little bit in the chapter on policy about how much the US is spending on kind of military and defense applications. And I think that there's also a question of it's hard to get a lot of that data because sometimes data on how military is developing some of these AI tools is quite classified or difficult to get. There was actually one of our data vendors, CSED, they did an analysis a few years ago where they tried to analyze and understand how much money the Chinese government was spending on AI-related military functions. And to do this analysis, they basically scraped the web of Chinese-related contracts. And as soon as they published their analysis, most of the websites they had scraped data from ceased to exist. And again, I think this is a really challenging thing to measure. I think the index is concerned about it, and we do our best where we can to kind of report data on trends about how there may be ethical misuse or those kinds of considerations. But I mean, there definitely is concern. All right, I think that wraps us up today. So again, I'll conclude by just saying a thank you to the audience in person that came out, the audience on Zoom.